do distance and midpoint. We're going to do everything from a graph today. So we're not going to do any formulas except for Pythagorean theorem. And let me go ahead and get the graph up here. I gave you guys graph paper so that you can graph everything accurately. So our first question is going to be, you need to draw an axis. Yes, it doesn't, yeah. Find the distance between, they'll fit at least in a 10 by 10. So, between negative 3, 7 and 2, 4. Okay, so we're going to find the distance between negative 2, 7, negative 3, 7, and 2, 4. So everything we're doing today, we're just going to graph it and figure it out. So negative 3, 7, we're going to plot that point, negative 3, positive 7. It's going to be right here. And 2, 4 is right here. And so we need to know the distance between those 2 points right there. Whenever students start doing this, have you guys done distance and midpoint before? I think you have. I think that you do it in 8th grade. But distance and midpoint, the mistake students make when they start doing this sometimes when they're doing it from a graph is they just want to count. And you can count as long as it's a horizontal or a vertical line. But you cannot count whenever it's a slanted line because you'd be like 1, 2, 3, 4. It wouldn't work. Okay? So what we're going to have to do instead is we need to make a triangle. Because if we make a triangle, you could either make the triangle on top, like this, or you could make the triangle on the bottom, like this. It doesn't matter which one you want there. Because those lines are vertical and horizontal. And we can count them. So when we count, I'm going to use this top one up here, but the bottom will be the same. 1, 2, 3, 4, 5. This side has a length of 5. And then this side is 1, 2, 3. So that has a side of 3. Okay? So for this, 3 and 5 are the legs of that triangle. So we're going to say 3 squared plus 5 squared equals, I'm going to use, you could use whatever you want. I'm going to use a D here for distance, D squared. So 3 squared is 9, 5 squared is 25. Together that's going to give us 34. That will equal D squared. There. And then, Aiden, how do we get rid of a square? Not divide. The square root. Square root. So we'll square root. And square root's kind of a type of dividing, but yeah. So we will, let's see, hold on. I need my calculator. Okay. You will be able to use a calculator on these, yes. 3 decimal places, yes. If you don't have it now, just follow along. You'll be okay. We'll get it whenever we start working on our own. So D is going to equal 5.8. Oh, how's that round? Because some of you guys can't round, and I know it. 5.831, because you're going to cut it off right here. The number behind that is a 9, which is bigger, 5 or bigger. So that rounds this up to a 1. So 5.831. And always stop to think whether or not that makes sense. A lot of times kids will forget to take that square root and they'll say the distance is 34. Would it make sense for this side to be 5 and this side to be 3 and this line to be 34? It'd be way too big, right? Kind of like Aiden was saying with the football question yesterday. It didn't make sense for that diagonal to be almost twice the length of the football field. So always stop and ask yourself if your answer makes sense. I always tell students, I had a girl, it's been years now, she was in one of the first classes I taught, and we were working on averages. It was a different class one we don't have now. We were working on averages, and we were finding the average shoe size of everybody in the room, and she got 24. And so what was concerning about the 24 is that she didn't say, Miss Hyatt, I got 24. I know I did something wrong. She just gave me the answer 24 and did not recognize that clearly had to be wrong. What she had done is this. You guys, there's something about permission forms. Okay. All right, that's just a question. It doesn't help. All right. The teacher that doesn't know either. So what she had done is like, if we're taking the average of some numbers, 1 plus 5 plus 9 plus 8 plus 6. There's 5 numbers. She divided it by 5. When you do that in the calculator, it only divides the last number by 5 instead of just adding them all together, so you would need to hit enter first. So I knew what she'd done, but she trusted that calculator so much that since she did on the calculator, she thought she was right. So always ask yourself if it makes sense at the end. You can save yourself from looking dumb a lot. That's always good, not to look like you're dumb. So always ask yourself there at the end. Okay. Like, for example, I'll give you this other. I need to give you a good warm up I came up with. But I was talking to this guy that was a college president, I think, of like a community college up in Virginia that I met a couple weeks ago. And he was saying that the nursing program was wanting to increase their math requirements because they were giving kids problems like, you have this medicine and it comes in 1/2 milligram tablets, and so if you are supposed to give the person this many milligrams per however much they weigh, per, let's say 50 pounds or something, then how many tablets should you give them? And one person was going to give that patient 340 tablets. It was supposed to be like 8 milligrams or something, which would be 16 tablets. He was going to give them 340 tablets. That'd probably kill them. I'm not sure what medicine it was. Thank goodness this happened in a classroom and not actually in a doctor's office. Huh? Well, if she did, I hope so. Or if she didn't, I hope she learned how wrong she was there before she moved on. But stuff like that's really important. So, like, you should always ask yourself, does this make sense? Does this seem right? You don't want something, way off, especially when you're talking about something like medicine that could have really negative effects if you, like, triple your dose of something that you should not take nearly as much of. That's why if you're going to be an anesthesiologist, the people that put you to sleep whenever you have to have surgery, that you have to go to school for a really long time, and you got to be a really smart person, because they are giving people lethal amounts of drugs a lot of times. Like, if they're off just a little bit, it'll kill them. Whenever I had to have a procedure done a while back, and the doctor, who thought he was being funny, told me that they were going to give me some medicine that would put me to sleep, and that the anesthesiologist would administer it. They were giving me, he told me the name. I can't remember the name. I just remember he said it was Michael Jackson's drug of choice. Which was not funny to say, because that drug killed Michael Jackson. And I was getting ready to take that same drug that killed Michael Jackson. So I was fine. I woke right back up. Didn't have any side effects. But I want my doctor to really know what they're doing. whenever they're administering things that could kill me, right? So, and not like could kill you if you had, not could kill you if you had like 5 times the amount. Like you could just accidentally double it and it could kill you. And so if you're going to be an anesthesiologist, you got to be a really smart person. I'm sure they get paid well. Yeah, you're going to get paid pretty well, but you have got to go to school for a pretty long time, and you've got to really know how to calculate all of that stuff well, because you have lives literally in your hands whenever you're doing that stuff. I, as a math teacher, I could teach you how to find distance and midpoint completely wrong. You could miss every problem. It wouldn't be good for your education, but you'd still be alive tomorrow if I did that wrong. So I don't mind the anesthesiologist getting paid a lot of money. I want them to be happy with their job and do what they do well. So let's do another problem. All right. Let's see. Let's do a different graph for this one because we're doing a different thing. So draw yourself another coordinate plane. All right. Let's see. There we go. Okay. Okay. So we're going to find the midpoint of line segment AB if A is at 3, -5, and B is at -1, -9. Okay. So, again, tomorrow I'm going to teach, or not tomorrow because tomorrow's day of service. On Thursday I'm going to teach you formulas and how to do this other ways. But right now, I just want us to think of it logically. What are we doing here? So we've got 3, -5. So let's graph 3, -5. I'm going to put an A right here. And then B is at -1, -9. So -1, -9. And so we are looking for the midpoint. The midpoint is the point that is halfway between those 2 points, the middle of that line. So if we're looking for that midpoint, this is how, if you're going to use a graph, this is what I tell students to do. Guess. You can usually guess fairly well. Okay? So I'm guessing that it's about right here. That looks about right. And then check. So from that midpoint, I'd have to go over 2, up 2, right? And then I want to check and make sure it's the same from the other side, over 2, up 2. So I got identical little triangles there, right? So if the triangles are identical, then the lengths of each one of those little sides are identical. So I would know that that point right there is my midpoint, and I can just read the coordinates off for that. That is 1, -7. So 1, -7. Okay. So, questions on that? Just guess and check to make sure it would make the same triangles on both sides. All right, let's try something else. Do a different graph for all of them. Find the perimeter of triangle ABC with A at 2, 1, B at -3, 5, and C at -3, -1. Okay, so we need to graph those points, A, B, and C. So A is at 2, 1. It'll be right here. B is at -3, 5. And C is at -3, -1. Let's see. Cole, remind me what a perimeter is. Well, no, it's not. Okay, length plus width would be correct for a rectangle. You're thinking area. Okay, you're thinking area. Nope. Okay, perimeter is just adding all the sides. Okay, so you could for any figure, it could be a triangle or a rectangle or a square or a dodecagon. It could be anything like that. It's just adding the length of all the sides. Okay, so if you're asked to do this, we need to find the length of all 3 of the sides, and then we need to add them together. Okay, so we could start. I would start with BC. Why would I start with BC? It's a straight line. You can just count it. 1, 2, 3, 4, 5, 6. So BC is going to be 6. AB and AC are going to take a little bit more work. Okay, so this side right here, that's 6. So for AB, I'm going to make myself a triangle. And let's see, let's count 1, 2, 3, 4 for this side, and 1, 2, 3, 4 for this side. So for AB, those are both the legs. Your right angle is here. So I would do 4 squared plus 4 squared equals that distance squared. So that's 16 plus 16. And 16 plus 16 is 32. And 1, 2, 3. That's just 4. Unless I graphed it wrong. Did I graph it wrong? I did graph it wrong, didn't I? No, 2, 1. I went to 2 instead of 3. You're right. These need to slide over. I graphed it wrong. Here's the downfall of relying on graphing. If you graph it wrong, you will miss the problem. So this is A. B is at -3, 5. Did that on purpose to teach you guys a lesson. Just checking to make sure you're paying attention. There we go. Okay, let's fix this. Okay, now it's 5. I don't know why it does this crazy thing. Why does it do that? Okay. Ugh. This thing is stupid. Okay, and that really should have been a 5 right there. Let's fix that as a 5. That makes that 25. And that, when we add it together, 25 and 16 is 41. And then we'll be taking the square root of that. Right now, I'm just going to leave it AB equals the square root of 41 because I don't really like decimals. Especially long decimals, and that one's going to be a long decimal. So I'm just going to leave it like that for right now. Okay? Because I don't need to know really what it is. I just need to know what they all are added together. So I'm just going to leave it. If you've got a decimal, that's fine. All right, questions on AB? All right, AC. We could draw a triangle here. And this side is 2. This side is 5. So I would have, for AC, I would have 2 squared plus 5 squared equals D squared. So that's 4 plus 25, which is going to give us 29, equals D squared. And we'll take the square root of that. So AC equals the square root of 29. And I like just saving it till the end so I don't have to worry about keeping all those long decimal places. So I've got all 3 of my lengths here. Here's BC, it's 6. AB is square root of 41. AC is 29, or square root of 29. So I'm just going to add those together. It'll depend on whether you got a newer or an older calculator. You just got to be a little bit careful with this. When I do 6 plus, when I do square root of 41, if you have an older calculator, yours is going to come up with the square root and a parenthesis. If you have a newer calculator, it's going to give you the square root sign and your number is going to be underneath it. So if you have an older calculator, make sure you close that parenthesis before you add the square root of 29. If you have a newer calculator, make sure you hit the over key before you add those together, or it'll be like a square root under a square root for that. So whenever we do this, we should get 17.788. So our perimeter is 17.788. So this problem is just a way for math teachers to make you have to find the distance 3 times. Okay, questions? All right, one more kind of problem I want us to look at for today. Okay, last one. You can turn it over on the back if you ran out of room. Okay. To write this one down, this will be our last one for today. So midpoint of line segment AC is B. If A is at 1, -2, and B is at 5, 1, what are the coordinates of C? Okay, are we finding the midpoint? We are not, because what letter represents the midpoint? B, right? The midpoint of line segment AC is B. So B, right here, this is our midpoint. Okay? So B is our midpoint. AC, those are the A and C are the endpoints. We already know what B is. So we're not finding the midpoint here. They're giving us the midpoint. So let's graph this. We've got 1, negative 2. So 1, negative 2 right here is our A. And then we've got 5, 1. That is our B. So if B, this is the midpoint. Okay, B is the midpoint. So that tells me C's got to be somewhere over here. Somewhere, right? So from a graph, do this. To get from A to B, I'd have to go up 3, to the right 4. Right, does that look right on your graph? Did I graph this one up correctly? Okay, so just go up 3, to the right 4 again. And there you will have your point C. Okay, make sure that you start at A, because if you start at B, you'll end up down here, which would be wrong. B is the midpoint, so you got to start at A and just figure out, how do I get from A to B? Well, up 3, right 4. So go up 3, right 4 again. And that gives you C. And I can see that the coordinates for that point are 9, 4. Okay, questions? Your homework is going to be the 4.1 assignment. And we're going to do numbers 1 through 7. And 13 through 16. Don't mark the others out. We're going to do some more work with those also. But 1 through 7 and 13 through 16. Okay? Now, here's the catch. If you get this done, you are not allowed to quit until the bell has rang. So if you get this all finished, then do some of the other problems as well. I just didn't want to give 1,000 problems for homework. But if you get finished, keep working until at least class is over. I think it'll take most of you till the end, or maybe a little further. So. Adam Settle.